All right, guys. So what we're talking about today, we're starting with, well, what we know so far. We already have a lot of information about sine of x, right? We learned how to graph that, cosine of x, and tangent of x. Okay, these are our basic trig functions. These are the standard trig functions. If you, these are the ones that are on your calculator. The difference with this and what we're starting is the reciprocals. The reciprocals are the cosecant of x, which is just 1 over the sine of x. The reciprocals, remember, are where it's on the other side of the fraction, where sine of x is really sine of x over 1. So the reciprocal of it we call the cosecant. Okay. I started with cosecant for today because we learned sine first. Okay. But the cosine, the reciprocal of that is the secant, okay, which is just the 1 over the cosine. So we're going to have to keep in mind as well, since the reciprocals are a trig function under 1, right? Since we have an x value in the denominator, we have to also keep in mind, we have to identify restrictions. So if you have 0 in the denominator, then you end up with, if you have 0 in the denominator, then you end up with a restriction. And the restrictions are going to be the asymptotes. Okay, the restrictions are going to be the asymptotes, because you can't have a value that makes a fraction 0. The reciprocal of tangent is the cotangent. Okay, and that's just 1 over the tangent of x. So we have these three. Today we're basically just going to focus on the cosecant. Okay, and you're like, oh man, there's 3 new graphs that I have to learn how to do, but it's actually totally based on the function that it comes from. The cosecant is so related to the sine, secant to the cosine, cotangent to the tangent, that we just really have to reference, okay, how did we graph the sine? And once you know how to graph the sine, you already know what the cosine is going to look like. It seems like it's going to be a lot more, but it's actually not. Okay, so let's see what else we have here. Let's see. I already got here. We got to show the restrictions and put this here as well. The restrictions are the asymptotes. Asymptotes. Okay. The restrictions are the asymptotes, and that's where the function cannot go past that point. It kind of jumps over that point. That's where we have our dashed lines. That's where it kind of informs the function and how it looks like in a graph. Okay. Now, when we're graphing, if I need to graph the cosecant, all I need to do is first graph the sine version. Graph the sine version. Okay. We know the asymptotes. Actually, we're going to learn right now that the asymptotes can be found from the restriction, but they're also where the regular function, the sine function, crosses either the x-intercepts or the midline. Okay. And it's easier to see actually, but I'm going to keep going through this. The cosecant graph touches the minimum and the maximum. I didn't finish that sentence. The minimum and maximum of the sine of x graph. Let's add that because I did not. So the cosecant, CSC, cosecant, right, touches the minimum and the maximum of the sine of x graph. You might be like, what, and what? Right? That's okay. I expect it to be a little bit kind of tricky right now. So get that last note in there, then I'm going to show you what I mean. Now, this is Desmos. We have right now showing, we have the sine of x. You can see on the left side of the screen. You guys see that pretty well here, huh? Good. So you can see that right now this is just the sine of x. And what do we have? It's the a sine bx minus c plus d. That's our standard equation for the sine function. But a is 1, b is 1, C is 0 and D is 0. So really what we're showing right now, even if I added one here, we're showing y is equal to the sine of x. You see how it's overlapping it? Right? So remember the sliders right now, A, B, C, and D are set up so that it's essentially, it is just the sine of x. But I'm going to keep the sliders here so we can manipulate it. Okay? So watch this. Here are some points. We know that we have 0, 0, pi over 2 and 1, pi and 0. We got a couple more. Okay. And if we were to reference a unit circle, these are, remember the sign, is the sign talking about the x values or the y values? Do you remember this one? The sign is talking about the x or the y. At home, what do you guys remember? So it was like cosine was talking about x or y, sine was talking about x or y, but which one was it? Do you guys remember that? Not offhand? No worries. Okay, make a note. Sine of x is talking about our y values as we rotate around a unit circle. So remember the unit circle, whoa, that's a unit circle, all right, okay. This is not nice. This is my 6-year-old niece made this unit circle. Awesome. All right, remember what we're talking about as we rotate around the unit circle. When we're talking about the sine function, we're talking about what's happening to the y values. What's happening to the y values? Remember how I had that one illustration? Maybe I can even pull it up really fast. Let's see if I have it handy. Sine this. I'm going to show it real quick. So remember, we had this animation where as it rotates around, right, it is tracking the y value, right? At 0, I stop it right here. If I stop it here where it's right at the top, right? Right? That's not even showing what I want you to show. Dang it. Sorry, guys. Online teaching. All right, look. If we back this up to where it's at 0, right? What is the y value up and down? It's 0. That's why the graph is going to be right here. If I rotate it and I get all the way up, the y value at this radian is at 1 as well. And then look what happens. We go down. If you just remember this, I'm just reminding you of this that we've seen before. And that's the full graph as we rotate around. Okay. So that's great. Let's go back to our other graph now. Oh no, you're gonna get a, I don't want you to see that yet. Let's do this. All right. So now we're back to the other graph. We're here at sine. This is just the sine graph. And we just figured out this is related to where the y value is as we rotate around the unit circle. Now, in looking at this, we know that from what we learned about cosecant, there's going to be some asymptotes. There's going to be some asymptotes where the midline was. So the midline is here. It's at 0, 0. Well, actually, it's just at y is equal to 0. I'm going to work backwards. I'm going to go ahead and show you what the secant looks like, and you'll see that it's like Wario. It's Mario's evil twin. So check this out. This is the secant, or excuse me, the cosecant graph. Okay. The cosecant graph meets the sine graph at the minimum and the maximum of the sine graph. Okay. And you can also see that. I could do this. You can also see that it goes up, right? It goes up. And this right here is an asymptote. This is an asymptote. And if I were to go ahead and add the asymptote, I'm going to do it right now. X equal to pi. That's one asymptote, right? It's right at that moment and point where it intersects our midline for the sine. So if I had to graph the cosecant, I would graph the sine first. And then you kind of have to just learn the pattern of this, right? I'm going to put the other one, it's 0. Is it to red? Okay. Here's the other asymptote. You see how this fits in there? It just fits between the asymptotes. If we back up, we could see it really is just a matter of there's some u's and some upside down u's. But the main thing about this is if you graph the sine function, then you know what the cosecant is going to look like. Because you're going to make your asymptotes for that sine function, whatever you graph, you're going to make them at these intercepts. Okay? And then from the minimum and the maximum, you go ahead and make the rest of the graph from that. Okay. So that is all abstract until we do an example problem. So let's go ahead and work on one. And then we'll try it on Desmos. So we looked over example 1 to some extent. So I want to actually start and look at example 2 here. So we have this graph. Go ahead and set up a graph to follow along with this work. So we're going to graph 2 cosecant of x plus 1. Alicia, I don't know what that was about, but yeah. And you know what I'm going to have handy is this, and I would encourage you to get it handy too, is the notes from graphing the sine. Because we're going to have to graph, oh, I see, my unit circle, got it. Yeah. We're gonna get this. It was from 331. It was like what we started with in this unit. So just have that handy, or maybe it's just going to be a matter of I need to write down this equation and remind you what a, b, c, and d are. Sine b x minus c plus d. Okay, so the main thing here is, okay, we want to graph the cosecant of x. So we want to graph y is equal to 2 times the cosecant of x plus 1. We have to first graph 2 sine of x plus 1. You see? If we graph the sine version of it, then we know where those asymptotes are going to go. We know where the minimum and max are going to go. And it's pretty much, cosecant is going to fit into the sine of x plus 1, 2 sine x plus 1. So let's go ahead and label what we got here. We have a is equal to 2. Put it over here. What else do we see? D is equal to 1. B is equal to 1 because it's 1x. C, there's no expression x minus c or x plus c. It would be in parentheses if there was a c value. So we know that c is equal to 0. D is equal. We have all of them. Okay. So let's see, what does this mean? What does this mean? If I go back to how we graph sine, remember that our d value is our midline. So we know that our midline, we go ahead and graph that first, the center line of the function. The midline is how it vertically transforms. And what we have is d is equal to 1. So I'm going to go here at 1. I'm going to put a dash line. Okay? Because the d value is the midline. Okay, so this is our midline. Okay. All right, what's next? Next, we got to find our starting point. We got to find the horizontal shift, because the sine of x usually starts at the origin. It starts here at 0. Right? Starts at the origin. It's been moved up, but then we have to move side to side. And let's see, is there any horizontal shift? A c value? No, c is 0. So we don't have any horizontal shift. So we know, since the sine function usually starts at the origin, but the midline has moved it up, it's got to start right here. You guys agree? Okay. What is next? All right, next we have to look at the frequency This is the number of cycles within 2 pi, interval. So to find the period, which is how long it takes before it repeats, we have to take 2 pi and divide it by the frequency. So let's go ahead and do that down here. Let's see, this is going to allow me to get 2 pi divided by the frequency, and we get our period is equal to 2 pi. Okay, that's important. So what it's saying is it's going to repeat after 2 pi. There's only one frequency, so we're going to go ahead and do, let's see, let's break it this far. Let's do this. So this is pi, this is 2 pi, pi over 2, 3 pi over 2. Okay, so categorizing your brain as well. The reason why these notes that I did were graphing sine and graphing cosine, it was because those are really related. Remember, those had kind of the same rules. Tangent looks different, right? But cosine and sine both have this general look to it. Okay, it's just where it starts. Okay, so let's see. I know it's going to go. It's going to go between 0 and 2 pi. Okay. And let's see, lastly, we had to look at the amplitude. Okay. This is from the midline to the maximum. So what that's saying is the amplitude is how far from the midline you're going in either direction, to the top and to the bottom, to the maximum and to the minimum. And what do we have for that? We have amplitude is 2. Amplitude is 2. So if this is 1, I have to go up here to 3. I have to go down here to -1, and that is going to be the maximum. That is going to be the minimum. Okay. Let's take a look at just how these graphs look. Remember, it starts, it goes to the maximum, goes back to the midline. And that is right in the middle before it goes down to the minimum and then goes back to the midline. So essentially, we can put a point at the starting point here where x is 0, at 0, 1 here. And then we could put another midline point at pi, a last midline point at 2 pi. And then let's go ahead and put our maximum, put our minimum, and we look like this. So, you're like, geez, I mean, that was so much work. This is most of the work. Finding and now graphing the cosecant is so easy. It's so quick. All right, trust me on this. What we're going to do is we're going to review back to the notes that we just had and look at this real quick. Because what we just learned was we graphed the sine version. The asymptotes are the x-intercepts, or where it intersects the midline. So that's where I'm going to go in here, and I'm with a different color. I'm going to look and see that the intersection for the sine version, the intersection along the midline are at these 3 points. You guys agree? That's where it goes up and comes down through it. So this is where I'm going to put my asymptotes. Okay, do them careful for this one. Make it nice and neat. You see? So you do the sine, you graph the sine, then you go back in and you put those asymptotes at the intersection of the midline. And then look, the last step, it is that easy. Watch. Cosecant graph touches the minimum and the maximum of the sine of x graph. So watch. It touches here. It touches here. And since these are asymptotes, it's going to keep getting closer to them but never touch them. Okay. So now all I have to do to finish the graph is, watch. Put some arrows showing they go on forever. Goes up. Goes up. And that is the graph. That is the graph. It comes together at the end really quick, right? You do all this work to graph the sine, and then it's really just asymptotes. Get it? All right, guys at home, any questions on that? How do you feel about that at home? Thumbs up, sideways, down? What you think? Well, what are you guys thinking here? Doable? Yeah. Right. And I think if we just review back and think, okay, we just really, if we're doing cosecant, we're graphing the sine, and then we're just putting those asymptotes in.
Basically doing the same thing, just adding
Another component, really, right? Yeah. Let me show you a couple things here, because I'm going to preview what we're going to do next, and you could see here, this was our graph. Let's get rid of these two things. So we had A was 2, right? What else do we have? B was 1, D was 1. So here's our graph right here. Let me see if I could show grid lines. I can. Okay. So, oh, this is, one sec. Okay, so we had it starting here, right? We had starting here. Okay. We had this point. We had this point here. Oh, it won't let me do it. Okay. And we had this point over here as well. Bummer. Okay, so those were the locations of the asymptotes, and that allows me to make this picture right here. That's the only way that I can actually make that shape. Okay. Now watch what happens. This is the sine curve and the cosecant. Watch this. Cosine, remember cosine and sine are different. Remember where they start? They start at different places. And let me put it back to 1 and 0. Okay, these are the standard places for it. Here's sine, remember it goes to the origin. Cosine, it's just shifted a little bit and it starts at 1. Now, cosine, or sine and cosecant look like this, right? Now watch what happens with cosine and secant. Same thing. Just in the same way that sine and cosine were the same thing, it was just shifted over a little bit. Secant and cosine and sine and cosecant are related in the same way. We can even put them all on top of each other and see here. It's the same thing, right? We can even do this and make it go crazy. Oh wow. Okay, stop. So this is the same process we're going to do when we look at secant and cosine the next session. But the basics are, in order to graph the cosecant version of it, all I have to remember is I got to graph the sine. I got to look and see where the midline is and where the function crosses the midline. That's where the asymptotes go. The minimum and maximum are the top. These are almost parabolas, not quite. Top of the curve and bottom of the curve. Okay. And that's about it. And we got like 5 minutes. So any questions? I know it's like a quick one. It's kind of quick. No questions? Let me show you then what we got for homework. This is working out. I could do that. All right, guys, take a look at this as you guys are wrapping up the work. We got in the classwork. I did not give you a ton for this. So this is the first one, cosecant. And you could see that all you really have to do is graph four different functions. Okay. So here are the 4 functions you got to graph. And you could also double check yourself with the Desmos calculator if you want to see if it's correct. But we only have 4 to graph. It's not so bad. And then on Thursday, we'll look at the secant. And then we'll have one more part to all of it. All right, let me go and stop the video. All right, guys at home.